Okay, hi everybody. Just wanted to do a quick conversion lecture video for you. We're going to talk about conversions using grams, milligrams, pounds, lots of good stuff. We're also going to talk about units of radiation measurements. First of all, we'll start with our smallest measurement, the mic. Okay, it is MIC, mic, for the microgram. Okay, that's why we pronounce it mic. So from mics to milligrams, you have 1,000 mics per 1 milligram of measure. Okay, so 1 mic equals 1/1000th of a milligram, or 0.001 milligrams. Okay, so if you have 5 mics, you will have 0.005 milligrams of whatever you are measuring. Okay, milligrams to grams. So in the metric system, it's fairly easy. Everything's pretty much the same thing. So you just have to remember what you're converting from and to. So you have 1,000 milligrams, 1,000 milligrams, 1,000 milligrams in 1 gram. So remember, a dollar bill, or the paper money that's used in the United States, is a weight or mass of 1 gram. All right, so if you cut that dollar bill into 1,000 pieces, you would have a milligram. And if you cut that milligram into 1,000 pieces, you would have a mic. Okay, so very small unit of measurement. Again, the conversion factor is 1 to 1,000. So if you have 1 milligram, you will have 1/1000th of a gram, or 0.001 grams. Right? Pretty straightforward. Grams to kilograms. Again, you have a conversion factor of 1,000. So 1 kilogram is 1,000 grams. 1 gram is, again, 1/1000th of a kilogram, or 0.001 kilograms. So if you have 10 grams, you have 0.01 kilograms. Cubic centimeter versus the milliliter. Okay, a milliliter is the liquid measurement, whereas a cc is the older way of talking about it. That's more of a solid measurement as opposed to a volume of liquid. So we've changed over. You will still get people that use cc, and it is interchangeable with milliliters. So if they have 5 cc's of the liquid versus 5 mLs, it's the exact same volume. Okay, again, 1,000 milliliters equals 1 liter. So 1 milliliter is 0.001 liters. So if you have 100 milliliters, you will have 0.01 liters. Okay. Miscellaneous. 1 kilogram equals 2.2 pounds. Why is this important? Most of the time, your system will have the patient's weight in kilograms. So you will need to, if you are familiar with your pound measurement, you will need to convert that over in your head. So if your patient weighs 100 kilograms, that patient weighs 220 pounds. Okay, so that's a quick and easy conversion, 2.2. 1 gallon equals 3.78 liters. 1 liter is 0.26 gallons. Okay. And it's interesting that we have the imperial gallon versus the US gallon. So there's, confusion. but a liter is a liter wherever you go. Radiation units. This is something that you might come across in the boards or on the boards. So we'll just go over that. We didn't go over it in class prior, but we will go over this again. You will see it again. This is just an introduction to the concept. Radioactivity. So whether the radioactive substance is naturally occurring, like plutonium, uranium, or if it is technetium that we use or manufactured to use in nuclear medicine. Okay, the older units or the common units are the Curie for radioactivity, and now it is the becquerel. So the SI units, or the international standard or system of units, is used everywhere except for pretty much here, just like the metric system. All right, so we are doing the conversion, but people still go with the older units of measurement very frequently. Okay, the absorbed dose. Absorbed dose means in your patient. So the absorbed dose is the rad. Okay, and the newer SI units is the gray. Now, the absorbed dose for the patient and the dose equivalent is the same volume of units, all right? So the dose equivalent here, the old version is our EM, okay? The E is for employee. So this is the occupational dose for you as a worker. Now, if you were to go in and get an exam done, you would then get a rad, not a rem. But as long as you are working, it is the sievert or the rem that we are talking about as the unit of dose that you are absorbing. Okay, and exposure itself is the Rinken, named after William Conrad Rinken, who discovered X-rays in 1895 in November. Okay. So the coulomb per kilogram is the SI units. The only ones that are really important to you guys are the gray and the sievert, the rad. Okay. So there's a whole bunch of different things on here. We're just going to focus on the items in red. Okay, 1 rad is the patient dose, is equal to 0.01 gray. All right, and the 1 rem, the occupational dose, is equal to 0.01 sievert. Okay, again, the only distinction between a gray and a sievert is who is being exposed, the patient or the worker. Okay. The worker is the sievert. You can say that the sievert is the exposed to the staff. So those both start with S. Okay. So if we have 100 rad under the old units, we have 1 gray. If we have 100 rem, we have 1 sievert. All right. So that's pretty much it for today. This information for the last 2 slides were obtained from this website here. Okay, so nice government website. All right, please let me know if you have any questions. I would be happy to answer them, and I look forward to talking to you soon. Thanks, guys.